For centuries, people have gazed at the night sky and imagined what it might be like to live among the stars. What would it be like to look back at Earth from a permanent home in space? Would we see borders between countries? Could we see the seasons change? Could we eat and breathe, and sleep and work? How would we feel? And how would our bodies react with no gravity to hold us in place? Do the laws of science behave in space as they do on Earth? How can we answer these questions, and what do they mean for the people of Earth?
Hey guys, my name is Kim Ong-Ray, and today we're going to talk about International Space Station for Physics ISU Part 1. The space station is a home in orbit. It's a large spacecraft where it orbits around Earth and it's a home for astronauts. The International Space Station is mainly used for science lab. Representatives from all over the world work together to build and use the station. The space station is about 220 miles per hour above the Earth and then travel at 17,500 miles per hour. In 1998, Russia launched the first piece of International Space Station to Russian space. The first crew arrived on November 2nd, 2000. NASA and its partners around the world finished the space station in 2011. The space station is the size of 5 bedroom house for 2 Boeing 747 jetliners. It can support a crew of 6 people plus a visitor. The station weighs almost 1 million pounds. It has space labs from the United States, Russia, Japan, and Europe. The space station has many parts. The parts are called modules. The first module had parts needed to make the space station work. Astronauts also live in those modules. Modules called nodes connect parts of the stations to each other. Labs on the space station let astronauts do research. On the sides of the space station are solar arrays. The arrays collect energy from the sun. They turn sunlight into electricity. Robot arms are attached outside. The robot arms help to build space station. They can also move astronauts around outside and control science experiments. Airlocks on the space station are like doors. Astronauts use them to go outside on the spacewalk. Docking pods are like doors too. The ports allow visiting spacecraft to connect to the space station. New crews and visitors enter station through the docking pods. Astronauts fly into the space station onto Russian soils. The crew members use the ports to move supplies onto the station.
From the not-so-far reaches of space aboard the International Space Station comes a floating ball of water, hovering in the air amidst the microgravity. But this isn't just any view of a ball of liquid. It's being shot in 4K UHD, a new type of camera that NASA says is capable of recording 4 times the resolution of normal high-definition cameras. The literally space-age camera catches NASA astronaut Scott Kelly injecting a bit of dye into the ball, causing it to change colors. Finally, Kelly adds an effervescent tablet, causing the ball to pulsate and change shape as it comes even closer to the camera's lens.
Hello everyone, my name is Mohammad Arshad Ali, and microgravity. Microgravity has a value of 1 times 10 to the power of negative 6 times the value of g. The condition of microgravity comes about whenever an object is in free fall. That is, if it falls faster and faster, accelerating with exactly the acceleration due to gravity. As soon as you drop something like an apple, it is in a state of free fall. Say the same is true if you throw something, it immediately starts falling towards the earth. But how does something fall around the earth? NASA uses a variety of facilities to create microgravity conditions. The most famous way is by aircraft flying in parabolic areas to create microgravity for tests and simulations that last 20 to 25 seconds. NASA's Johnson Space Center, for example, operates a C-9 low-G flight research aircraft, also known as the Vomit Comet. Well, it can make several trips each year to NASA Glenn in support of ground-based microgravity research. Its predecessor, a KC-135 aircraft, was used to shoot the weightless scenes in the movie Apollo 13. And the facilities most likely to be misconstrued as anti-gravity chambers are NASA's drop towers. So basically, they just drop things inside the tower. That's it. Specifically, NASA Glenn has the Zero Gravity Research Facility. It is a large shaft some 500 feet deep that allows test packages to free fall in a vacuum for just over 5 seconds. In this state of free fall, weightlessness or near microgravity can be obtained. NASA Glenn also has a 2.2 second drop tower. Boom!
Hi everybody, my name is Kenny, and I'm going to talk about the satellites in circular motion. A communication satellite in synchronous orbit, that is a satellite orbiting Earth with a speed matching that of Earth's own rotation, is an example of an artificial satellite with a constant orbital radius. The orbital period, represented by the symbol T, is the time it takes an object to complete one orbit around another object. A geosynchronous satellite's orbital speed leads to an orbital period that exactly matches Earth's rotational period. To an observer on Earth, geostationary orbit is a type of geosynchronous orbit in which the satellite orbits directly over the equator. To an observer on Earth, a geostationary satellite will appear to remain fixed in the same point in the sky at all times. And to find G, you need gravitational constant times mass over radius squared. And to find centripetal acceleration, you need velocity squared over radius. And to find satellite in circular orbit, gravitational force provides centripetal force, which is A equals to G. And to find velocity, you need a square root of gravitational constant times mass over radius. When Newton developed the idea of the universal gravitation, he also theorized that the same force that pulls object to Earth also keeps the Moon in its orbit. One difference, of course, is that the Moon does not hit Earth's surface. The Moon orbits Earth at a distance from Earth's center called the orbital radius. That's all.
Cool.
Hi, my name is Syama Afi, and today I'll present how does ISS benefits the environment. The International Space Station was originally designed as an observatory, laboratory and factory in Earth orbit. The space station offers unique support for observing the Earth's ecosystem with automated and hand-on apparatus. This helps astronauts to explain and observe what they witness in real time. The station crews gathered camera images of events for unnatural events like volcano eruptions or earthquakes. The station provides collecting data on environmental change and global climate using automated and crew-operated Earth observation payloads. International Space Station also helps water purification on worldwide. Drinkable water is essential for human life, but many people around the world lack of access to clean water. With the help from the space station, Areas with limited clean water can now gain access to advanced purification system and water filtration, improving the environment. In the station, a group of engineers developed cutting-edge water purification system that can recycle air and water, helping them to save resources dramatically. Not only it helps to save water, the station helps coral reef resources too. Island and coastal islands rely on reef ecosystem to aid local fisheries, serving as barriers to protect from surge and storm and making revenue from tourism. However, in few years, the scientific community alarmed crisis of global warming, ocean warming, and human activities like fishing and tourism on coral reef ecosystem. In order to help the ecosystem, astronauts take photographs from the station to provide important perspective on coral reef, geography, related and land habitats and coastal equipment. With the help of International Space Station, the Earth and space environment is slowly getting better and better.